From the outset, it was meant to be a vehicle that delivers value and excitement. Thus, the Mazda Mx-3 was conceived, designed, and developed to be unique and expressive. This video will explore the main features and service points of the Mx-3 and its exciting new K8 DOHC V6 engine. In Part 1, a basic outline of the Mx-3 will be introduced. In Part 2, we will give an overview of the engine control system of the K8 DOHC V6 engine. And in Part 3, helpful pointers regarding the diagnosis connector, engine tune-up, and necessary test equipment will be presented. To begin, let's take a look at the components you see here. The Mx-3 is available with a modified version of the B6 SOHC engine and the all-new K8 DOHC V6 engine. This K8 engine combines excellent performance, unparalleled smoothness, and exceptional fuel economy. It is also one of the lightest, quietest, and most compact of currently mass-produced V6 engines. This all-aluminum engine features double overhead camshafts on each bank of cylinders, which operate 4 valves per cylinder. And it employs a direct drive mechanism for its overhead camshafts. This camshaft drive mechanism incorporates friction gears that fit tightly against the driving gears to prevent gear backlash and noise. To further improve its overall design and strength, the cylinder block is split at the crankshaft centerline. The upper block has cast-in iron cylinder liners, while the lower block has cast-in iron-bearing cap carriers, forming an extremely sturdy unit. Next is the suspension. The Mx-3 was designed and built to display superb road handling by instantly responding to driver input and tracking with little noticeable body roll or sway. The front suspension is McPherson strut type. And the rear suspension is Mazda's highly regarded twin trapezoidal link arrangement. A transverse member that ties the front AR mount bases together. And a performance rod strengthening the rear suspension work together to improve the vehicle's overall stability. The latest generation electronically controlled non-integral four-wheel type anti-lock brake system, like that found on the 323BG two-wheel drive model, is standard on the K8 engine-equipped Mx-3. This important safety feature consists of the electronic ABS control unit. Four wheel speed sensors and sensor rotors to monitor the speed of each wheel. And a remotely mounted compact hydraulic unit that regulates the hydraulic pressure to control braking. Now let's see how this new ABS operates. The hydraulic unit consists of a flow control valve to control fluid pressure, a pump motor to return fluid in the system, a buffer chamber to absorb the fluid pressure impulses, and a damper chamber to decrease pump vibration and noise. During normal brake operation, there's no signal from the control unit, so the fluid pressure from the master cylinder goes directly through the flow control valve to the brake caliper. When the brake fluid pressure becomes high and a wheel is likely to lock, the control unit sends a signal for pressure reduction to the solenoid valve. First, the solenoid valve opens to prevent any further increase in fluid pressure, and the pump motor begins to operate. Then fluid pressure pushes the flow control valve down to reduce the pressure in the brake caliper. When the wheel again begins to grip the road and increase in speed, the control unit causes the pressure to again be reduced, beginning the cycle anew. The engine control system of the K8 EGI engine features the very latest in engine management systems. We will concentrate on the main mechanisms listed here. To achieve outstanding smoothness and power, Mazda employs a sequential fuel injection system on the K8 engine. To make understanding of this system easier, let's see what the actual injection looks like as it occurs. This then is the actual injection while the engine is running. But please note, this is for demonstration only and very dangerous. So don't use this as a checking method. This system is controlled by the engine control unit mounted behind the center console. For the ECU to control the basic fuel injection amount, the airflow meter and the intake air thermosensor output intake air amount signals. And the crankshaft angle sensor, crank angle sensor 2, installed at the crankshaft, outputs engine speed signals. These three signals are sent to the ECU for the necessary calculations. The ECU also decides the optimum fuel injection correction amounts by using the throttle sensor signal, the water thermosensor signal, and the oxygen sensor signal. To give better performance and prevent fuel vapor lock, side-feeding injectors are employed. This is because as the fuel flows around as well as through the injectors, they are cooled better for increased injection performance. The excellence of the K8 engine is enhanced by its air induction system, the VRIS. VRIS stands for Variable Resonance Induction System. Evolving from Mazda's dynamic supercharge effect induction system, the VRIS goes a step further. For this engine, the resonance and inertia supercharging effects are fully exploited in 6 zones within the engine's RPM range, instead of 3 zones as with the previous VRIS. The working of the various valves in the intake system controls this performance, enhancing operation. The VRIS thus ensures smooth and quick engine response. To detect the crankshaft angle correctly, and for accurate engine control, the Mx-3 employs a Hall effect type crankshaft angle sensor, Crank Angle Sensor 1, within the distributor. In the distributor, there are two sets of vanes. These are for the NE1 signal, and this is for the G signal. The vanes pass through their respective Hall sensor. The two Hall sensors are this one for the NE1 signal and this for the G signal. When the engine is running, the vanes passing through the Hall sensors thus create the crank angle signal. When the vane is between the magnet and the Hall sensor pickup, there is no voltage. And when the vane is not between them, voltage is created. This type of signal is considered best for accurate input to the ECU. For precise control of the fuel injection timing and the ignition timing, the ECU also uses another crank angle sensor, called Crank Angle Sensor 2. Because the NE1 and G signals may display a small amount of error caused by stretching of the timing belt, the crank angle sensor, with 6 evenly spaced projections, is mounted on the crankshaft pulley. When the engine is running, this crank angle sensor outputs precise crank position signals to the ECU. The exhaust gas recirculation system, or EGR, recirculates a controlled amount of exhaust gas into the intake manifold to reduce the combustion temperature and thus reduce NOx emissions. It consists of the EGR valve, the EGR position sensor, and 2 solenoid valves. When the engine is cold, idling, decelerating, or operating at high speed or heavy load cruising, operation of the EGR is stopped to improve engine smoothness and drivability. During acceleration or warm-up, the amount of EGR gas introduced to the cylinders is restricted. During normal cruising, and at times other than those already mentioned, the ECU controls the EGR gas amount as necessary to meet the operating conditions. In Part 3, we will consider a few important service points. These are the use of the diagnosis connector, tune-up procedures, camshaft installation, information about inspection of the injectors, oxygen sensor sensitivity inspection, and cooling fan system inspection. Like other recent Mazda vehicles, a diagnosis connector is used for accessing self-diagnosis information and for connecting test equipment. Providing improved serviceability is the goal of this concentrated check connector. One section of the diagnosis connector consists of 17 pins, to which the Mazda System Selector SST is connected. To check each function, turn the system selector to the specified number as shown. The other 8-pin section is used for testing individual components, in this case, the fuel pump. Now let's turn our attention to engine tune-up. As an initial part of the tune-up, some important preparations must be carried out, after which the ignition timing and idle speed can be checked and adjusted as necessary. In order to ensure that the engine speed is stabilized before beginning the tune-up, be sure to do the following. Always warm up the engine to the normal operating temperature. And be sure all electrical loads such as the blower motor, headlights, and so on are off. After this is done, connect the System Selector SST to the vehicle. Then connect a timing light to the battery and number 1 high-tension lead. Next, connect a tachometer to the diagnosis connector's IG negative terminal. Now set the System Select switch of the System Selector to position 1 and the Test switch to Self-Test. We can now carry out the actual tune-up. First is the ignition timing adjustment. Verify that the idle speed is within specification. Then, using the timing light, check the ignition timing. If it's incorrect, loosen and turn the distributor to adjust it. Next comes the idle speed adjustment. Check to see if the idle speed is within specification. If it isn't correct, adjust it by turning this air adjusting screw. The K8 engine features a unique camshaft drive mechanism, so installation must be done according to the specified directions in the workshop manual. But basically, first apply clean engine oil to the camshaft journals and to the saddles in the cylinder head. Then install the camshafts so that the alignment marks on the intake and exhaust camshaft gears are aligned. The fuel injector harness has been changed to a unique molded type for size and weight reduction, better serviceability, reduced vibration, and improved reliability. To check the injectors, this new Injector Checker SST has been introduced. Let's look at how to use it. After releasing the fuel pressure and removing the fuel delivery pipes, Reconnect the fuel main hose and fuel return hose to the delivery pipes. Then, using a jumper wire, jump the fuel pump check and ground terminals of the diagnosis connector. These terminals are labeled FP and GND. Attach the injector checker to the injector harness. Turn the ignition switch to on. And set the dial of the SST for the injector to be tested. Now hold the test button of the tester depressed for 15 seconds and measure the injection volume. For this engine, it should be 35 to 37 cc's. Because there are two oxygen sensors in the system, they must be checked separately for accurate evaluation. Do this as follows. After warming up the engine, connect the system selector and self-diagnosis checker SSTs to the vehicle. Now run the engine at between 2,000 to 3,000 RPM and check to see if the monitor lamp flashes at least 8 times within a 10-second period. If it doesn't, the intake system and the fuel system must be checked. If they are found to be okay, check the oxygen sensor and the related wiring. The check just performed checks the left bank oxygen sensor. To check the oxygen sensor on the right bank, perform the operation again while depressing the brake pedal. Inspection of the electrical cooling fan system has been modified for improved serviceability. First, connect the test engine and ground terminals, labeled TEN and GND, on the diagnosis connector using a jumper wire. Then turn the ignition switch to the on position. Now turn the throttle lever to actuate the cooling fan. If it doesn't begin to run, check the cooling fan system. That concludes our description of the main mechanisms and equipment of the exciting new MX-3. For more details, please refer to the MX-3 Training Manual and Workshop Manual. We thank you for your attention and urge you to do your best to service the MX-3 to ensure that your customers are satisfied with Mazda as well as your service center. Thank you.